So let me just bring up the system architecture again real quick. Let's see. So Monday, I was working through building up the supervision hierarchy for the conduit SQS adapter. So I built this part here, which is sort of the interface between conduit and conduit SQS. I built this part, which sets up the topology for SQS, so that's creating queues, stuff like that. And then yesterday, I was working on the polar supervisor in the polar. So the polar supervisor is just responsible for supervising any polars. The polars, there's one per queue that you're subscribed to, and they're basically just spinning and consuming from SQS. So today I'm going to start by writing the part that actually talks to SQS to pull information and turn that into a conduit message that can then be passed to subscribers. If I get through all that, then I'll start working on this part here. So this part is setting up workers that will be able to consume those messages that are being pulled from a queue. So with that out of the way, let's get started. So yesterday we were working on this polar. The polar is a gen stage producer. So gen stage producer, and it's responsible for handling demand that's sent to it and also getting messages. We did all that, and then we stubbed out the SQS part so that we could just test that we were correctly handling demand. So now I'm going to start working on this SQS bit to get messages. All right, so let's pop this guy open. So previously, this SQS part was set up to create a topology. One thing that is kind of clear from that, just looking at this now, is that it took a lot of work to actually build up the attributes and stuff like that to create the topology, and it sort of hides the intent of this library or this module. So the first step I actually want to do is sort of pull out a lot of this logic here, specifically for publish. Setup is actually not too bad. So setup, yeah, setup's a lot better. So let me just take all this. Actually, is that where I want to pull it out? So it's basically this get options function that is a little, does a lot. And so it sort of hides the intent of the rest of this module. So I'm going to pull that out into its own SQS options module. So I'm just going to create a new folder called SQS and create a new file called options. And then we're just going to take everything in here, get options down, and place that in this module. So then we've got to define the public API here. So I'm actually going to call this from now, because we're basically saying build options from this message with these additional options passed in. So then we can just go over here and we can do an alias for that. So alias conduit SQS SQS options, and then here we can just replace get options with options dot from message ops. So that simplifies this module a little bit. It sort of gives it a little bit clearer intent. So it has these two public methods now, and it has this sort of this method specifically for the topology. So now we want to define a method called get messages. Actually, we should run our test first. Make sure that passes. Cool, we got a failure. So unused import. We were using this import in our options, so we'll just put that in here. And right, so what we're seeing here is the tests are failing, and the tests are failing because we're using this injects library to basically give us an easy definition of a function that changes if we're in test versus dev and prod. So in dev and prod, that function will return a module, and in test it'll return a module defined by config or the default module. And one thing that it also checks is just that if you're overriding the default module, you're not providing any functions that are different from that module. So that's just to ensure that the two APIs are compatible between the two. Cool. So we can fix that just by defining get messages for on this module here. So what are the 4 arguments though? We get a queue, fetch amount, subscriber ops, and adapter ops. Queue, fetch amount, subscriber ops, and adapter ops. And right now that can just return empty, and this should pass now. All right, and we just get warnings about the these guys here because we just defined them, but we're not using them. Cool. So now what we want to do is look at the SQS clients API to see how we can get messages. I have to look to see what functions are available here. Receive messages, that's the one we want. So this accepts a queue, which we have, and then some options. So here we want to pass the subscriber options. We're going to turn this into a pipeline though. So this basically builds a request for us to get options, and then we actually need to make the request. And here we would pass the adapter ops. And we can get in the body. So I believe this returns a list of messages, but we'll verify that by actually making a call to the API. And then we'll add a little bit more here so that we can take an SQS message and turn it into a conduit message, which has a specific API. And we're not using this fetch amount, so we need to figure out how we can pass that along. If we look at this, oops. So that keeps going away. So that takes a queue name and receive message ops. If we look at the module itself, it's not showing us that. We can look at it online. So receive message ops. That's what we want to look at. We're going to want to fetch all the attributes. That's so that we can fill in the attributes on the conduit message and also fill in the headers. And then we also want to get all the message attribute names. So we'll do all on that as well. And then max number of messages. I'll have to check the AWS docs about that. Seems odd to me that it would limit it to 1 to 10. And then visibility timeout and wait time seconds. So a cool thing about the SQS libraries generally is that they do what's called long polling. So if you make a request and there's nothing there immediately, they'll keep the connection open, and if anything comes within the wait time seconds, then they'll send that along as a response to your request. So you don't have to keep making lots of requests. You can just make one request, say it lasts 20 seconds to pull in things, and then you get whatever's in there. You make another request, 20 seconds. So you don't have to make 20 calls every second. You can just make one call in 20 seconds, and it'll give you all the messages. And so I believe if it reaches whatever your fetch limit is, it'll end the request at that time and just send all of that along. So if you have a wait time of 20 seconds, but you're interested in getting 100 messages, if it has 100 messages as soon as you connect, it'll give you that. If it has 100 messages 10 seconds after you connect, it'll give you it after 10 seconds. And then after 20 seconds, it'll just give you what it's got. So let's look at the API over here. So receive message. So what I'm looking for here is what I can use for the fetch amount. Wow, okay, so it is actually 10. That surprises me. I would have expected it to be like hundreds at least. Okay. So we're actually gonna do. All right, so that was an option for here. So maybe I don't want it to So what I'm thinking about right now is that maybe I don't want to specify a particular option here, in so that um, there's sort of a one-to-one mapping between SQS's options and the options you would pass to conduit. The alternate would be that there's uh, sort of a standardized name that every conduit adapter would use, like fetch amount. Um, I think maybe I might lean towards a standard mapping that uh, every adapter would use. Mm. That may be a decision for 1.0 API, not for now. Right now, I think I'm just going to use what SQS provides. So, the wrong dots. So, max number of messages. I'm going to make a couple changes because I want this to be reflected. So if subscriber ops just contains max number of messages, then in the polar, we can just pull max number of messages. We'll default that to 10. And let's see, so we should ensure that we always get something that is 10 or less. So we're going to do the min of these guys here. So if you specify max number of messages, that's 48, and the current demand is 48, you're still just going to pull out 10 because that's all you're allowed to pull out. So that was fetch limit. Do I reuse that other than here? Yes, here. Fetch amount is used there. This should really be fetch amount. So that was sort of a bug, I think, because we should have been checking with the amount we actually used to fetch, not the amount that the user told us to fetch. Is that right? Yeah. Yeah, that's right. Okay, let's rerun the test just to make sure that that didn't break anything. Oops, and let's see, so what's changed here? Is this just that we got a completely new message? I think we messed something up here. So min of fetch limit. So say fetch limit is 10. Well, let's say it's 100. And current demand is 1,000. We pick 100. And then we do min of 110. We get 10. So that seems fine. The issue here, though, is that in the test we were assuming we'd get 5 back, and instead we got 10 back, and so then our demand went down to 0. So which one failed? $77. So this one failed. Here we were expecting to get 3 messages back and demand to go down to 7. And instead we got let's see, that's 8 messages back. And yeah, so we're just not accounting for the 8 messages. So what went wrong there? So let's look at the state. So state is 10, fetch limit is 5. So let's go look at this. Oops. Demand 10, fetch limit 5. So fetch limit 5 is what we pull out of, oh, we changed the name of this. Alright, that was good. So we should be able to rerun that and everything passes again. Alright, good. Let's just look at our diff. Alright, removed all that. And we added that. Alright. So that's fine. Okay, back to this. So let's start adding a test for this. SQS test. And we're going to describe get messages 4. Actually, the thing I'm realizing is that since we're pulling out the max number of messages here from the subscriber ops, but we're just going to pass that in as subscriber ops. We don't need to really pass the fetch amount here. You know, I take that back. We do need to pass the fetch amount because this is really describing the maximum amount that we want to pull. But since we're handling the demand here, providing back pressure, we want to limit the amount that is actually pulled back. Alright, so what that means is that I want to actually override the fetch amount. We should call that, we should make that consistent, consistent naming. So in the polar, we should call that max number of messages, max number of messages, max number of messages, like so. That way we just won't get confused about whenever we change names, stuff like that. Let's see, so so we need to override the option here. So since it's a keyword list, and generally options at the beginning win, we're going to try just prepending this to the beginning. So max number of messages, and then we can, oh, we didn't rename it here. So we can prepend it like that. So I'm just going to pull this out above here, just because it's rather long now. Cool. And then I think that's probably about it for now. So we're going to go back to our test now. So it's still described for. So let's test that when we call get messages, it returns a list of messages. With attributes mapped to properties, conduit attributes, and headers. So that's our eventual goal, and we'll eventually get there. So we want to use a cassette here because we're going to be making an API call. So here it'll be receive, and we're going to do SQS get messages. Q is going to be Q, or conduit test. And then the max number of messages here, we can just put 10. There won't be that many actually on the queue, so it'll be fine. And then subscriber ops. For that, we might add something there, but for now I'm going to leave it empty. And then adapter ops, so we can actually receive that here. So ops config. Cool. Let's just see what that does. All right. Undefined, describe 3. Oh, I put the options there instead of on the actual test block. So, in receive, we made a request, and we got back a response with some messages that we set up in a previous test, presumably. So let's actually just print out what those are. So let's just do this. Actually, we can do an assertion. That'll also print it out. So just it equals some object. Okay, so what did we get back? So it's a map that has messages. We didn't pull back any attributes, which we'll want. We did get back a body though. We didn't pull back any message attributes. We did get some other stuff though. Okay, so let's go back over to here. So we definitely want to, let's see. So we sort of want to have some defaults for the subscriber ops. And we want them to be overridable in most cases, except for probably this max number of messages. That's just because we're handling the demand there. But the other ones, we should allow the user to pick what they're going to get, but have reasonable defaults. So let's make this a function. So let's call this build subscriber ops. For now, at least. And I'm going to change the way that I do this one. So instead of doing this map prefix, I'm going to use a pipeline and just do keyword dot put that. So now it's just set to that no matter what. And then we can put defaults in for some of these other values. So let's do keyword put new. So this will only override it if it's not already there. So we can say, actually we need to go look at what those options are. But so attribute names is what we want, and then we want to do all there. Same thing with message attributes. We want both of those. Like that. And so we've got that option. We've got that option. We've got that option. And the user can set those, but they'll just default to whatever the library provides if they're not specified. So that's fine. Okay, so that looks good. And we don't need to do anything to customize adapter ops. Alright, so I'm going to delete, let's see, the publish test, VCR, just so it'll actually put new messages on the queue. Oops. SQS 37. Oh, I forgot to pass that in. This is really long now, so I'm just going to make it its own line again. And so that's now an argument here. And then that should compile. So we got a failing test, but that's actually this test, so we're not too worried about that. All the other tests passed, and we have published a new message essentially by doing this. So let's actually go ahead and delete this VCR now. And when we rerun the test, we'll get failure, but we'll get a message with more information in it. Cool. So you can see now the attributes are all filled out. And same with the message attributes. Let's see, handle. Cool. We may want to pull out this request ID even though it's not on the message itself. So what I'm going to do is we're going to change this to get in. Well, I want the request ID as well. So we're going to actually, I think, build a library specifically for handling the body here. Or not library, a function. So we're going to call this just similar to options here. We're going to have something like message. And we're going to turn that into a conduit message. So let's do message here. To conduit message. So that'll take the body of the request and pipe it into this function, which will then do a little bit more complex work on. So let's define that file. So this will be conduit SQS, SQS message. And we'll define the function, what do we call that? To conduit message. It should be messages because it'll be a list. So it's technically a body here. I'm trying to think of what to name this. Let's not think about that for a second. So actually, let's just pattern match on it so we don't need to think about a name for that variable. That's one of the cool things about Elixir. You can just sort of say, I'm not going to name this thing. I'm going to name the things inside that thing. So I want to get the request ID out of here. This is going to be JSON though, I believe. Let's look at this. So messages. Oh no, these are atoms. Okay. So request ID, and then messages. Cool. So we're going to map over messages. Enum.map messages and we're just going to call a function in this module to conduit message. We're going to pass %1, and then we want to pass the request ID. All right, so here we have a couple things of interest. We can take a look at that. So we're going to have this set of attributes. We're going to have message attributes, and then we're going to have a message ID, receipt handle. Somewhere in here there's also a body. There it is. So let's start pulling that stuff out. So let's pull out the body, since that's interesting. And also in here, we're going to want the conduit message helpers. Cool. So here we can do %message, and we're going to put body. And then we're gonna, let's see, so we can put the request ID. So there's no specific property for that, so we're just going to put that as a header. Request ID is request ID. And we're going to where was yeah, okay. So headers, their keys have to be strings, so that's why this is a string. That's what I was thinking about. I was like, oh, I'm pulling that out of the message here, but no, I'm not. I'm putting it into the message headers there, and so it has to be a string. So sent timestamp. So we actually have a attribute called put created at for that sort of thing. So we're going to then grab out sent timestamp here. Let's actually just copy this. There. So I don't have to go back and forth anymore. All right. So now we can start mapping these guys into the right spot. So all of these attributes we're likely going to just stick in as headers because they don't have a specific property on the conduit message. Some of the message attributes will have a specific slot that I can fit in, so we'll define some functions for those. And then is there anything else here? So I guess some of these top level properties will actually also stick on. as headers. So let's handle those real quick because those will be simple. Request ID is the second argument here. Attributes, I'm just going to call those adders here. Then body, we already pulled out. MD5 of body, I guess we could do that. Just going to call that MD5. Then message attributes, which I misspelled. And we're just going to call those message adders. That goes there. Oh wait, no, sorry. That encompasses all of these. Then message ID. We'll need to pull out. And then receipt handle. And that's the last thing in the message. We're just going to call that handle. So this is way too long for a method signature, so I think I'm just going to break this up like this. I need to fix my key repeat. Things are way too slow here. Oh, key repeat, keyboard. Fast, delay until repeat short. And there's also a setting for I don't know. Yeah, that's much better. It's painful sort of going around before. All right. So we'll do it like that. So now we've got body. We'll need to handle adders separately. MD5 we can just put in as a header now. MD5 of body. So everything else is a message attribute or a attribute. So we're going to define our own functions for that. So let's do put attributes and pass in adders there. And then we're going to do put message attributes and pass in message adders. Cool. So that'll be the entirety of that function there. Then we can define another function, put attributes, So let's just take out the part here that is attributes. So this from here to here. So we're just going to paste that there and comment it out. So that's a map, string keys. So I believe these are always available. We should take a look at Amazon stocks for receive message. So let's look at the response. So I don't see anything here about which attributes can we return. But presumably you can list them out as part of the request, so it must be specifiable here. So approximate first receive, approximate receive count, sender ID, set timestamp, message deduplication ID. So all these are great. Presumably, if we're asking for all, we should get any one of these, though. So my inclination right now is to just shove everything here in headers, and then maybe treat a couple as special properties. So to do that, we can just do headers here, headers. We need a first argument of the message. So we're going to do enum.map. Actually, we're going to reduce here. So we're going to reduce the adders into our message. We're going to pass function here. So this is going to get the first argument of our adders, which will be name and a value, and then our message. And here we can just do put header, message, name, and value. Since these are already string keys, it should work perfectly fine with put header. Yeah, so that's that part. Now we want to do something with these message attributes all the way up to here. Alright, so these are going to be a little bit more interesting because they've got some extra properties on them. So they're not just key value pairs. So what we're gonna start with something similar. So we're gonna do enum.reduce adders message, and function, we're going to receive the name and the adder, and then our message. Cool. So here we want to, we're going to define another function called put message adder. So we're going to care about the name and the parts of the adder, and we're going to want the message. So put message attribute, message, name, adder. So we're going to define that. And we're going to start by defining the special cases. So here we should get a name. So there are a couple of these that are going to be special properties. And so those are the ones that are available on conduit message. Let's just write that here so we can look at the dots. So if we just hover over that, we can see the public fields. So one is source, destination, user ID, correlation ID, message ID, content type, content encoding, created by and created at. So can we copy from here? Yeah, sweet. Duh. I copied way more than I wanted to. So we won't actually use source and destination because those will come from somewhere else. And we won't need status or body or headers. So these are the guys we want to set here. So one will be user ID, and the adder should match this pattern of, let's see, so binary value. So it's not going to be binary. It'll have a value, and that should already be of the type that we want. So we can just do value, and we can then do put user ID, message, and the user ID, the value. So I feel like most of these are going to be pretty similar. So what we can do is we can use a when clause for the name. And we can say it's inside the list of user ID, correlation ID, message ID, content type. It's getting a little long, so we're going to wrap that. Content type, content encoding, created by, and created at. So that should use all of these values verbatim. These are generally strings or numbers anyways. So there's no special handling that really needs to be had there. And then for things that aren't that, we're going to shove them into headers. Oh, crap. I just realized that definitely don't want to use that function if I'm accepting all these values. Let's do this. We can just do map.put. So since all of these are safe, since those are explicit values on the message, we can actually just turn the name into a atom here. So let's just do string to existing atom. That should be fine because it's already defined on the struct. Then we can do name. Cool. So here we're getting a message, a name, and a struct. So if the value has the right type, we can just pull it out directly. So let's look at one of these guys. Ignore. So ignore has a data type of number.boolean. So let's handle that. So data type equals number.boolean. So in this case, we can do put header message and name, and then we want to convert the value into a boolean, so we can just do if value is equal to 1, do true, else false, like so. Alright, then put message attribute, message name. So when the value is, or actually when the data type is let's see, so we have value. So when it's number, we can just do it as is. Whenever it's string, we can do it as is. Yeah, we're not really doing anything special for the rest of these, so let's just pass them through directly as is. So this will be sort of our catch-all case. name and value. So cool. So that should handle all of those, and then the special case is there. So what are we missing? So we get request ID, we get messages. We are missing we're not setting where the message is from, so we're going to pass this along too. So we'll just pass that as an initial argument. So Q, and we'll pass that here. We'll pass that here. And just here we'll put source, Q, and we should be good. Alright, so let's go rerun our test. We should get something back that's very different from this. Oh, we failed on something. So conduit SQS message struct is undefined. I think so we're trying to use that instead of thinks we're trying to use this instead of this. So line 21. Wait, not here. Line 21. There. Oh, oops. We have conflicting aliases. Which one do I like better here? Let's do this. So then let's get rid of that. And I can rerun this. It doesn't like what we did. So that's not defined. We tried to call what? So we called toConduit message. We passed it the body and a Q. And then over here, toConduit message, body and a Q. That looks defined. Is that private? Nope. Alright, so we called conduit with messages and request ID. Request ID. And the Q. So that looks fine to me. Oh, oh. It's even telling me which one I should be using. I forgot an S there. So this should be 2 conduit messages. Alright, now we get a different failure. So, first argument is the message itself. That doesn't matter for what we're trying to do. We got a value that has a data type of number. Oh wait, these are not atom keys. Or these are atom keys, not string keys. So that's going to be a problem. So let's go over here. This should be value. This should be value. This should be data type. Atom. This should be value. Right, so that should fix that part. Uh-oh. Oh. I must have left the hash rocket in there. Alright. Okay, now we're getting back a conduit message that has a bunch of stuff on it. We're not using message ID and message. I'm blind. 56 of the, no, sorry. I was looking at the error dot the warning. Line 32. It's line 32, we're pulling out message ID and not using it. So let's put that as a header right now. Cool. All right. Yeah, so that looks pretty good. Over here in the SQS test, we can now make an assertion about what we're going to get back here. So this is going to be a message. So we can run this now and we'll get a partial match. So the body will be high. And the correlation ID will be 1. Let's just copy some of these. Headers will be all that stuff. It's supposed to be that. Hello, viewer. Let me know if you have any questions about anything I'm doing. So right now I'm writing a test. Basically, I've made a request to grab messages from the SQS API, and I'm mapping those into I'm mapping the messages that get returned from SQS into a conduit message, which has a specific API. So I'm almost done with that. Some of these values I think I don't want to test. So I'm going to switch the order of here and just do an assertion on a pattern match so that I can ignore some of the values. So let's do equals here. So like this long value here. So this guy here I don't care about. Quest ID. I don't care about the value. Same for this. And this. Mainly just care about, is there something there? And so if the key's there, that should be sufficient to know if there's something there. So same thing for here. There. These are the actual attributes that I passed along. So I want those to be there. That one doesn't matter. Ignore true, MD5. Alright. So, alright, that looks good. So now we can rerun our tests, see if we got what we want. Cool. So now we are receiving messages. So I'll do this for the benefit of you since you're watching. So if we look at our architecture here, so the gist is we're building an adapter. So conduit SQS is the entry point for that adapter. So it receives a couple things. It receives a topology, which is basically a description of the queues that should exist in SQS for this to run. It'll receive subscribers. So the queues that the subscribers are going to listen to, their options and stuff like that. And then it also has just a function where you can publish a message. And so conduit SQS implements the publish functionality. For the topology, it passes that information off to this setup process, and that setup process then creates all the queues. The polar supervisor is responsible for supervising each of the polars. There will be one polar per queue. Each of the polars basically gets told some amount of demand by these workers. So basically a worker can say, I can handle 1,000 messages. So my demand is 1,000. If I have 5 workers, then I have 5,000 demand. And so then the polars are basically just going to try and handle as much of that demand as they can. So they're just going to keep polling against the SQS API, trying to provide work. But yeah, so we've sort of finished this side of the tree. And now we need to handle this part, and then I'll come back and handle this activates piece. All right. So all of our tests are passing. We should commit what we have. Get status. Okay, so we can add everything there and check that in. So what did we do here? We added message retrieval. Cool. So now what I'm interested to do is let's go down the supervision tree. So we have conduit SQS, which is starting our worker group supervisor. So that's going to care about subscriber and ops, and also the broker. Okay, so now in our worker group supervisor, did I have an extra wrapping there for some reason? So in the worker group supervisor, we're going to get broker, subscriber, subscribers, and ops. We're just going to pass those through. Like so. So now we're going to build our children based on the subscribers. So we can just do children equals subscribers enum.map. And here we want, let's see, so we're going to do a function. So this is a map of name to tuple of, let's see, so subscriber and subscriber ops. Like so. So now we want to define a child spec for that. So that's going to be a, well, actually we're not going to directly we're going to create a supervisor for each subscriber because we may have multiple workers under that subscriber. So here we're actually going to do supervisor. So the module that we're going to use for that is going to be conduit SQS worker supervisor. The args that we're going to pass: broker, subscriber, subops, and ops. So those ops are the adapter options. So that should be our children, and that'll be one for one. Um, since we are um, since we're creating uh, multiple children of this supervisor that are going to have the same module, we need to give them a unique ID. So what we can do here is just use essentially this module plus the subscriber, which will also be a module. I'm going to split that over a couple lines. Cool. So let's add a test for this. So this is the worker group supervisor. Yeah, that's right. Test. So this can be async true, because we're just going to be unit testing this. So we want to describe init1 test returns child specs for each subscriber. So now we can just alias that module. That'll just make it easier to call here. So I'm going to take that name and call init on that, and we're going to pass it some set of options. So this is going to return a couple things. The first thing is okay. The second thing is the supervisor ops. What do I call that elsewhere? Polar supervisor test. Call that. Shouldn't have called that adapter ops. Let's call that soup ops. So we're going to have something similar to this. And child specs. So it'll be 1 for 1 through 5. And then our child specs won't be that. So our first argument that we're passing into here is our broker. So we can just define something to pass there. It doesn't have to exist. Then subscribers, and then finally ops. So we're just going to do empty list for ops, since those just get passed through. So then our subscribers is going to be a map, names. Do we use the name here? We don't. think we need that name so that we can tell the broker what we're receiving it for. So let's pass that name along as well. So we can actually just run this and see what fails. So undefined broker, conduit SQS 18. So that's actually in this file here. Line 18, broker is not defined. Oh, because we have it underscored. All right. Worker group supervisor, line 8. Line 8 on its we didn't finish defining that. It's actually the way it's defined there, we're actually going to we're going to work because there's essentially nothing in the set, so it's going to return an empty list. So let's just call this test. And then we can just put test here, and then an empty set of options. And do another one as well. I should double check to make sure that these are actually strings now. The best way for me to check that is to look at the conduit SQS test. So these are actually atoms. So let's make them atoms here. I used XUnit test instead of XUnit case here. So that's why I was complaining about the scribe not being defined. Alright. So one thing that failed is just we'd previously written a test for conduit SQS test, and now we started passing new options, and so our test failed because we're not specifying those options here. So let's just copy that. And we can go to the conduit SQS test, and the spot where we had empty options, we just need to fill those in. And we're going to break the line right there. Looks like we have some mismatched stuff. So this is for that tuple, this is for the map, and then we need to close let's just copy that whole line. everything before permanent. So that looks better. If we rerun tests, we expect that one to pass. And now our child specs for this have come through. Oh, we messed up the pattern match. So, in the worker group supervisor test, it should actually be a tuple here. And now we just fail because we have different child specs. So we can take those and then we can look at them to make sure that they're correct after we format them. So this ends here. And we'll break let's break here and here and the same here. Cool. So what we get is our ID for our child spec, the thing to run to start our child spec, and then some options for supervising that child spec, and then just the name of the module. And then we get the same stuff here, differences being the module there, the name that we pass in, the module there, but otherwise same. Cool. So let's run that, and let's check that in. So we implemented the worker group supervisor. So now we're going to do the worker supervisor. So let's create a new file here. Worker supervisor. So this is going to be supervisor. I think I forgot to do that for this one. No, I did already. So this is going to have very similar stuff, so we're going to just copy this for now. Alright, so supervisor, start link, this module. So we want to actually grab the ops that are getting passed here. And update those here. Here. Like so. And then we're going to figure out how to create a number of children. Oops, this has an extra S. So no, we'll no longer have subscribers. Here we're actually going to take the sub ops and maybe also the ops to decide how many workers we want for each of the subscribers. So we're going to call that worker pool. So we're going to first look in the sub-ops, and then if not there, then we'll look in the ops. So we can just do keyword .get sub-ops. The key will just be, it should be worker pool size. And then default will be another keyword fetch. From ops, worker pool size, and then we're just going to pick a value right now, so 5. So if neither of those are there, it'll get 5. Okay, so here we can do a range from 1 to worker pool size. And then we can do enum.map on that. Function. So the arguments here will just be the num. And then we're going to be creating workers. The module will be just conduit SQS worker. The args will basically be the same args that we're getting passed in here. So we can just do that. And then, do we need anything else? All right, we need to specify an ID. So here we can do just conduit SQS worker. And we can just give it the num. And now let's write a test for that. So async case, and we're going to do async true. And we're going to describe init1 and let's see, so I want to test returns child specs for workers. So I want to do something about mentioning the number of workers that are specified in the ops. So we call that pool worker pool size. equal to worker pool size. All right, so we're going to alias as always. We're going to call init, and we're going to pass in our args. So first thing is the broker. Second thing is name, so test the subscriber. Then our subscriber ops, and finally our adapter ops. So here for the adapter ops, I'm going to specify the worker pool size equal to 2. Then we can assert that that equals okay tuple soup ops and child specs. So then we can do assert soup ops equals so it'll be 1 for 1 and 3 and 5, which are the defaults for max restarts and max seconds. Assert child specs equals list, and we're just going to run this to see what we get there. Right, so we can copy these, format it, and then see if that's what we expect. Alright, so break here. We can break here. And we can break here. And we will break here. And cool. So what we got, so we got ID equal to the worker and then the number. Same thing here. So as for our range, we did 1 to worker pool size, which is 2 here. We see we're going to do a worker start link with these options, the broker that we passed in, test that we passed in, subscriber, list, that. And then normal expected options there. Cool. So that looks good. Let's just run the tests, make sure that works. It does. So let's go ahead and check that in. Implement worker supervisor test. Not test, just the worker supervisor. Cool. So now we just need to create the workers. So, well, I guess I'll create the worker test. Worker test EXS. I really want to create this worker .x. So this is going to be a gen stage. I forget everything I need to define here, so we can go look at the docs. So gen stage. We're defining a consumer, Um, so this is what we want to look at. We can just take these guys here. And we'll customize them. So this should be this module. And we're going to be accepting the arguments that we specified in worker supervisor, which is going to be this set of stuff here. So here the state does matter. So we're going to define a module under here for state. That's just going to be a struct, and it's going to have the same stuff that we're passing in. So each of these is going to be an atom, though. We should call this adapter arms. And this subscriber arms. Okay, so here we want to define the state. So let's just broker name, subscriber, subscriber ops. Adapter ops. Like so. And let's just double check the function signature for that callback. So init1, we're doing this. There's no options that you can pass for your consumer, is there? Oh, subscribe to. Actually, that one will be very important. Yeah. So that one will require a little bit of thinking because we need to know essentially which queue we're trying to subscribe to. And here. Well, I'm not going to worry about that just yet, but we are going to do subscribe to here. I'll just go pass the empty list right now. Okay, and so then for handle events, we're going to get a list of messages. We want to iterate through those messages, and for each of them, we want to call broker receives so actually let's pull some of this stuff out of the state. Name. So broker is going to receive name, and then yet, but we can look at the documentation. So conduit broker dot. Oh, right. We have to define our own. Let's go look at. Let's just go look at the docs for conduit. Or the source, rather. So the receives function is defined on broker itself, I believe. No, so it's defined in incoming scope. Yeah, okay. So it takes a name and a message. Oh, we didn't need to pass around ops everywhere. It looks like. That's unfortunate that I was doing all that work. We just need to know the name and the message. And here we don't actually even care about the subscriber module. That's right, I forgot that Conduit did all this work. Cool. So we just need name and message. So really simple implementation here. Get rid of. So we need broker, we need name, and we need the message, which will be one of the events. So I should go call these messages. So really simple implementation would be just enum.each messages, and then we could do broker ampersand broker dot receives name, and then ampersand 1. Like so. So it won't actually be that simple, but it's almost that simple. We actually want to protect this process in the event that those crash. So we will probably do something to handle that. But otherwise, yeah, we're pretty close. It's being done. So it's 8:30 now, so I'm going to stop here and pick up from here tomorrow. It was fun.